Good evening, everyone. My name is Alessandro Gallone, and for our project, we did the ScubaPro Mark 25 and then the G200 second stage. These are regulators used for scuba diving. The Mark 25 is a top-of-the-line, chrome-bodied regulator. So going from outside to inside, the parts that I did was this dust cover, as well as the spacer between the dust cover, the tank valve, and the central body. This dust cover essentially holds dust and other particulates from getting into those main bodies of the regulator. The next part is this spacer. It essentially protects the spring from running directly against the central body. The spring was kind of fun to do. Did it with GSD and then padded it out. It's a steel spring with a plastic case around it. The spring rides next to that rubber gasket, and then on top of the spacer gasket below it, which protects the chrome of the piston from the effects of the spring itself. As I said before, was a chrome body and plastic lower piece with the O-rings to let it move back and forth. The second piece that we did was the G200, which is the second stage. This is the main part that you actually breathe off of. You can see it as completely assembled right here. The mouthpiece, the case, the cover. So starting from the front of the cover is the purge button, then goes into the spring, external case. There's the diaphragm that moves back and forth as you breathe. The case also has the gaskets, which holds the diaphragm in place. Inside, it reveals the actual integral components. That was the part that I did. This little lever right here is what actually moves up against the diaphragm, which lets you breathe in and out. It moves the poppet valve on the inside. The other portion that I did was the mouthpiece. So the mouthpiece was mostly with part design, but a little bit of GSD to get those curvatures. It was actually kind of interesting because it showed me the importance of doing things in a proper order, because when I tried to do those external shapes to them, it actually undid all of the central pieces, so I had to cut everything out and then repad it, and essentially it looks like the part twice. Going over to the central case, it's a steel container that contains everything that allows you to breathe off of it. That's the jam nut that keeps the hose in place. Pressure regulator puts tension on the spring to let you breathe easier or more difficult. O-ring that goes with it. Cover that goes between the spring and the adjustment valve. Then you've got the case itself. The case I did mostly with part design, as well as a little bit of, actually it was all entirely part design. The threads were the ribbed portion of this that had to be padded around, otherwise the rest of it was all part design. Inside of this you've got the poppet valve and the spring. Poppet valve is what moves back and forth, allowing the air to pass through that chamber right there. That screw right there also changes how much air can actually flow through it at any given time. Steel valve you actually see right across those faces, which is what moves back and forth as you breathe. This tab was probably the more difficult ones to do. It was mostly part design, but getting those shapes properly was the most difficult part of that. But that's everything that I did. Thank you very much.
Hey guys, this is Paula. I'm here to show you guys some of my parts I made for the dive-in regulator, specifically the yoke, the diaphragm, and the cover. So this piece is the yoke. It goes to the MK25. It was probably the hardest part for the MK25 that I had to build, just because of geometry that you guys can see. The angles were a bit tricky. It was obviously hard to measure it. I had to use some guessing as well as obviously geometry and math to figure it out. So I just created the base layer, and then from there I would use just to pad out to make it thicker on the face, like you can see right there. And then from there I would make the bottom of the base, which was a bit difficult because obviously it wasn't a perfect hexagon, but I did manage to do it. Once I got it, it was pretty easy. From there I just padded it out. I made the bottom base hole, as you can see, and then from there I would just use the fillet command to round out all of the edges of the yoke. Each part on there was had a different fillet size, which was kind of hard to figure out because obviously if it was too big I couldn't actually uh, fillet the rest of the piece. And then from there I just made the threads, as you guys can see, using the helix command on GSD, and then slotting it all the way around. So not too bad, but it did take a while, but obviously once I got it, it was cake, right? So the next piece I'll show you guys should be the diaphragm. The actual diaphragm was very tricky to do. As you can see, it took me a long time to figure this guy out, just because every time I would make it, it would literally look like a UFO spacecraft. I had to use a lot of some of part design and then a lot of GSD. As you can see, that's the outer circle that I used on part design. And then the grooves on the inside was as well on part designs, just creating a hole and then offsetting that hole. And then as well as the other internal components for the diaphragm. But then from there, I had to use surfaces to create that converging look, and I had to fill some of those. I had to join some of the pieces. I had to extract parts. So it was a bit of a challenge. I tried it as numerous of ways. I tried to just shaft it all the way around. It just did not work, in my opinion. It made it look like a UFO, but from there I just decided just to use GSD, and then the top black plastic piece was very easy. That was just straight part design. And then the last piece was the cover, that the diaphragm would go inside of that, and it's obviously made out of plastic, and that one wasn't too bad. It was just tedious to figure out all of the sizing, since I just decided to shaft that all the way around and then just add the holes afterwards. So to measure everything was very hard, but once I figured it out, it was easy. As you can see, that was the shape that it turned out to be. And then from there, I just added the triangular holes using the circle pattern. And then from there, I would use the helix command on GSD to create the threads, and then use the rib command to make the external threads from there. So thanks guys a lot. It was a lot of fun doing this project. This class was amazing. I learned a lot, and I can't wait to actually get to use more on CATIA. I guess talking a little bit more on this part, it was a bit tricky because I accidentally made it too big, and like I said, to adjust the sizing on the yoke was a bit difficult, but again, once I got it, it was cakewalk.
Good afternoon, everybody. My name is Sean Parsons. Today I'm going to be talking about the G200 ScubaPro regulator, particularly the purple surface you see here, along with this cover. To assemble this molded body was mostly GSD, and I will pull it up and kind of go through a step-by-step. The first thing that was done is just using the standard plane, create a circle to the proper dimensions, offset a plane up for the height, and then finally offset another plane to the overall height without any of these features. Once those are done, you create a multi-section surface, which would turn it that yellow, which is just a surface and not a solid, as we all know. Finally, you would come in here and just add all these different features independently. For this area, I'll call this the mouthpiece because it kind of looks like it. Created a plane, extruded up, created another plane, and extruded to the overall dimensions. To create this cylinder, I offset a plane right in the middle, created the shape, cylinder to the proper dimensions, and extruded both ways, kind of similar to a mirrored pad. To create the exterior front faces, I offset a plane to one of these sides, made a general shape with the interior voids and the screw hole void. And then extruded to the proper dimensions and use symmetry for the other side. For this flat plane, this flat surface, I used a plane at a 45-degree angle to the surface and extruded properly. For the cover, it's actually simple to make. The hardest thing was actually getting the screw holes to line up and verify there was no interference between any of these extrusions.